Swayam Prabha. Digital India. Educated India.
Okay, this lecture we will cover this concept of what we call crashing. So crashing is nothing like but reducing the duration of a project by reducing the duration of an activity, and we also call this time cost trade off, and we will see in a few minutes why we call this time cost trade off. This is the first lecture. There will be another lecture which will again we will work out problems in network and project crashing. So we will cover these topics specifically. One is the difference between fast tracking versus crashing, then looking at relationship between activity direct costs, activity durations and the assumptions in these, the procedure for finding the minimum direct cost for crash project duration, this will take bulk of our time today, and finally the influence of indirect cost and relationship between total cost and project duration. So these are the learning objectives for this session. Now let us get to our favorite project. It is a simple what we call the ABCD project, and as you can see here we have the 14-day completion, and let us assume or let us say that the person who gave you this project wants it done in 10 days. Right now it is 14. What are your options?
Reduce the project duration between activities.
So which project duration would I reduce? What activity duration would I reduce? Is there anything else other than, so one is I reduce duration of activities. Yes, so I have to focus on critical activities and reduce the duration of critical activities. Now I can, so right now the critical path is going through ACD. So one option is to reduce either activity A, C or D, and right now we do not have enough information on what. But for example this is I want to reduce it by 4 days, this activity is only 3-day duration. So I could actually reduce say this by 2, this by 1, this by 1. There are combinations of this which I could reduce. Is there any other way? We discussed something yes in the last class when we did the bridge problem. Yes, so I could try to do more things in parallel, and that is what we call fast tracking. Okay, so it is not a standard definition but a very well used definition. If I try to parallelize more things, it is fast tracking. So here is there anything I can parallelize? Right now based on the relationships no, but if I could somehow start D before 11 or start B before A finishes, if I could start parallelizing, but then I had to break these relationships. Okay, so if we actually look at the ways you can reduce project duration, we can say fast tracking where we perform activities in parallel, or crashing which is reducing duration of activities to reduce project duration. So what we are going to deal with in this session is crashing. Okay, fast tracking is possible, but obviously we and in practice fast tracking is something that is used commonly, but as far as our network sequence goes, we do not want to change out the relationships as of now. We will talk about more from a theoretical perspective how crashing can be done. We will look at change of execution sequence or duration will certainly have an impact on cost. We are again not looking at execution sequence, we are going to look at duration, and we will look at this time cost trade off. We will look at the analysis of this to find the minimum overall project cost for a specified project duration. So we will take these elements and we move forward. So like we discussed, the focus here is on crashing. Now some terminology when we talk about crashing, so it is very kind of when you hear of project crashing you think of negative things, what is happening, but this is an accepted terminology. Basically crashing is reducing activity time by expending additional resources. Okay, or there are other ways to do it too. We have definition of, so far we have only talked about duration. Okay, when we talk about project crashing we talk about normal duration, we talk about crash duration, and this is with respect to an activity initially. Normal duration is the duration we have been using right now for all of our CPM analysis. There is also a crash duration which we will come to later. Now more importantly, we also have a normal cost and a crash cost. Okay, so the normal cost is what we spend to do this in a normal duration. A crash cost is when I start compressing the activity, what is my cost that is going to happen. Now if you take a look at these definitions and these terms, what do you think is the relationship between cost and duration here? Duration decreases, cost will increase. Why? This is, remember, we are talking with respect to only an activity. We are not talking with respect to the project here. We are talking with only respect to the activity. So
most likely when you reduce duration, that is by employing additional resources.
right. So when you reduce duration, it's by employing additional resources. So we will come to the ways we can reduce duration. We have to employ additional resources. What else?
New technologies.
Yes, so we have adopt new technology. So I know instead of using a particular method, I will go in for a more, like say prefab or something, reduce the duration there, in which case I have to pay more for it for the activity. Overall project, we will have to see how the reduction of duration affects, that is coming later. I might use alternate construction materials.
The demand for manpower and all the material is reduced. I mean, we have to procure it in a very short period of time.
Right. So I will be paying a premium. If I want to mobilize more people on site, I might have to pay a premium. If I need more material, etc., I might have to pay a premium for it. Okay. So if I use alternate construction material, for example, self-compacting concrete will reduce my durations, but I might have to pay additional cost for getting that in. My formwork have to be different. I can work in multiple shifts. Okay, but every time you work in multiple shifts, it's not the same cost. People who work in the night shift have to be paid more. So it will cost for the same output, I'll have to pay more for it. Okay, but my duration, my calendar duration will reduce. Overtime work, again I have to pay more for overtime work. Bringing in higher capacity equipment. Okay, again it will, I can get more output for it, but my cost might be more. Most likely it is going to be more. We talked about this, putting in additional workers, which means now I have a fairly crowded work site or work area, in which case the productivity will be lower. Output might increase, but the productivity will be lower. Okay, so in all these, it's been found that reducing duration of an activity will typically result in increased cost. And if we look at the relationship, so here I have activity and I have the time and the cost, and again I'm very I want you to note this is activity time cost relationship. We will come into project time cost later. So we look at the curve here. Okay, so we typically you find that the relationship is as time increases, okay, the cost will decrease, and then you actually might just continue this way if I am taking only direct cost, and there is a normal duration, which is we base it on normal productivity. Okay, we will call this is the normal time or duration, and this is the normal cost. Okay, and as we reduce the duration, we come into the crash time or the crash cost. Now while this is kind of, people have shown and calculated this is the actual relationship, you will have to make assumptions on this if we have to work with it kind of in a classroom context. Okay, so one assumption is we take a piecewise linear, we assume this is a piecewise linear relationship, in which case there is 2 steps, or a simpler assumption is to make a fully linear relationship, in which case it is one step from normal time and normal cost to crash time and crash cost. So this simplification assumption we make it for our calculations further. While we know that this is actually some kind of non-linearity is there, we know there are any effective ways of making piecewise linear to model the non-linearity or model the non-linearity directly. For our purposes right now we are just going to make a full linear assumption. Okay, now what will the slope of this line indicate?
Cost per unit time.
Cost per unit time,
Increase in cost.
Increase in cost per, so for each day of crashing, yeah, each day of crashing, how much additional money do I have to spend for that activity? Okay, so we have this term which we have to use, which is the the cost per unit time, and we are looking at it from a cost you have to spend point of view. So we are just defining it as crash cost minus normal cost divided by normal time minus crash time. Okay, so that will give us the how much money I have to spend for each day of decrease in duration. Okay, so this is a basic concept.